Hey, IB girls. Integration by substitution. Some of our problems are going to get pretty complicated. And one of the ways to make those complicated problems a little bit easier is to replace something in with something else, do our integration, and substitute it back in. It's going to be called U substitution. So we're going to be using the letter U. I don't actually know why we use the letter U. That might be something to Google or for me or you. So let's look into that. Anyways, let's talk about derivative notation. So hopefully this will make a little bit more sense. So if you remember when we had the derivative, or when we had an equation of y, maybe equals 3x squared plus 6x, and we took the derivative, we ended up with dy over dx because when we took the derivative of y, that's dy, the derivative of this, dx. So we took on the left side, the derivative with respect to y, and on the right side, the derivative with respect to x. So for all of these, we have dy equals whatever that derivative was, dx. So here in a little bit, that's going to help us when we're going through and solving those integration problems, because remember how there's that dx at the end of our integration problems? That's what we're going to use. Okay, so we're going to use these to integrate really complicated functions, and here's what you want to look for. You want to look for part of the function that's the derivative of another part. So we're going to have one part be equal to u, and then we'll take its derivative, right? And then we're going to plug its derivative back in. So we want that derivative and something else in the function to cancel each other out. That's the goal. So we're looking for something that is the derivative of something else in that function. So the best way to do these is to attack them just head on. That's the best way to learn it, so let's give it a shot. The first one we're going to do to find this indefinite integral of 3x squared plus 5x, that quantity to the fourth power, times x plus 5. So you might be looking at this and your first instinct might be, okay, so I'm going to multiply all this out to the fourth power and then multiply it by that, and then I'll take the integral. Have fun with that. That sounds like I would want to punch myself in the face, but all right. Here's what you might notice. 3x squared plus 5x. If I take the derivative of that, that's how I get 6x plus 5, right? So here's what I'm going to do. I'm going to say that u is equal to 3x squared plus 5x. Okay? Now, if I take the derivative of this, I'm going to have du equals, oopsies, 6x plus 5, all of that, dx, right? Okay, so we want to rewrite this problem right here. So here's what I know. I still have an integral, but this time 3x squared plus 5x, that's equal to u. So I'm going to put u in right there. That's going to be to the fourth power, because right here, that was to the fourth power. And then we had, after that, 6x plus 5. And then we have dx, right? Okay. Well, over here, we could get dx by itself, right? dx is being multiplied by x plus 5. So to get dx by itself, I need to divide by x plus 5. So du divided by x plus 5. No! Sorry, animals. Equals dx. So now I'm going to take what dx is equal to and substitute him in. So now they have the integral of u to the 4th. Actually, I'm going to make this a little bit bigger. U to the 4th times 6x plus 5 times, and then in for dx goes du over 6x plus 5. So our goal is reached. If you notice, 6x plus 5 and 6x plus 5, one is up on the top, one is down on the bottom, so that means they cancel out, they divide away. So that's why we were looking for the derivative of 1 to be somewhere inside of that function. Okay, so these guys will cancel out. So now I just have the integral of u to the 4th du. So now we just use the rule that we have before in all of our other stuff. We're supposed to add 1 to the power and divide by the new power. And add plus c onto the end. Now, my equation was this. It didn't have u's in it, right? So now we replace what u was equal to back in. So when we replace u back in, we have 3x squared plus 5x to the 5th power over 5. And then don't forget that plus c there on the end. So now that we've seen it in action once, we're going to look at a few more problems and practice it a little bit more. These definitely take some practice, but you'll get used to it, don't worry. All right, so here we've got another one. We want to find the indefinite integral of the cubed root of x squared minus 3x times 2x minus 3. So the first thing we want to look for is part of my function the derivative of another part of my function. So right here, x squared minus 3x, the derivative of x squared minus 3x is 2x minus 3. Oh, there he is. So u is going to be equal to x squared minus 3x. So I'm going to take the derivative of u. That means I have du equals, the derivative of x squared is 2x minus, and the derivative of 3x is 3. All of that dx. So now 2x minus 3 in dx are being multiplied, and here in a second having dx being equal to something would be helpful. So to get dx by itself, I would have to divide by 2x minus 3 on both sides. So I end up with du over 2x minus 3 equals dx. Right. So now let's go through and replace things in this equation that would make our lives a little bit easier. So here we go. We have a cube root of, and we decided that x squared minus 3x is going to be equal to u. So now I have the cubed root of u times 2x minus 3 times, and then we know dx is equal to du over 2x minus 3. So then I get multiplied by du over 2x minus 3. All right, so since 2x minus 3 is over 2x minus 3, those two pieces divide away and cancel. So now when I have to take the derivative of, the integral of the cubed root of u du, that's a lot easier than this guy right here. So when we start taking the antiderivative of this, I would rewrite it as a exponent instead of a radical. So the cubed root of u is the same thing as u to the 1/3 power. We still have got that du on there. And now we'll take the antiderivative. So we've got u, we have to add 1 to our power. So that's to the 4/3 power now, divided by what my new power is, which is 4/3. And then we have to have a plus c at the end. So it is painful for me to have a fraction and a fraction that shouldn't be happening. I need to multiply by the reciprocal. So I know 3 is going to be in the numerator of that fraction. 4 is going to be in the denominator of that fraction. Now, instead of having u, I'm going to replace in what u was equal to into my answer. I need to replace it back in. So that was x squared minus 3x. And that is to the 4/3 power. And then, of course, we need the plus c at the end. Okay, we got this. 2 more. We can do it. Okay, so the x e to the 4x squared plus 1. Well, the derivative of 4x squared plus 1 isn't x, but it will kind of cancel out bits and pieces that are annoying to us. And all that will be left over are constants or coefficients that we can just pull out front and make our lives a whole lot easier. So in this case, the derivative of x is just 1. So taking the derivative of that and substituting it in would not be very helpful. So then let's go ahead and call u 4x squared plus 1. All right, so u equals 4x squared plus 1. Then we have to find our derivative. So the derivative of u is du. The derivative of 4x squared is 8x. The derivative of 1 is 0, and then that was with respect to x, so I have dx over on that side. And then just like before, we want to get dx by itself. So I'm going to divide by 8x on both sides. All right, good deal. So let's substitute things into our expression that will make our lives a little bit easier. So we've got this big old integral, and then we have x. If putting that over 1 makes you feel good, let's do that. Then we had e, and we said that 4x squared plus 1 is equal to u. So I'm going to replace that with a u right there. And if you want to put that over 1, feel free. And then we said that dx was equal to du over 8x. So now we can go through and simplify. So I have an 8 in a numerator and an x in a numerator and an x in a denominator. So that means those x's divide away and cancel out. So now I just have that 8 in a denominator. So I can just pull out that 1/8. And then I still have the integral of e to the u du. So, what's the integral of e to the u? The integral of e to the u is e to the u. The constant that was being multiplied still comes over and multiplies. So, 1/8. And then we'll have a plus c at the end. So to complete this problem, all we have to do is take what u was equal to and replace it back in. So now we have 1/8 e to the 4x squared plus 1 power, and then plus c there at the end. All right, one more for practice. Well, together, and then you'll have some independent practice tomorrow. I'm going to give you a couple of different ways to practice, whichever one works well for you. Oh boy. Okay, so it says, let's see, we got 12x cubed minus 3x squared over 4x to the 4th minus 3x cubed. So you might be tempted to try to factor this, and you can take a closer look at this, but there's really nothing to factor. Nothing's going to cancel out nicely without going and doing some substitution like we have before. So if we look which one is the derivative of something else, 3 times 4. Yeah, so if we take the denominator, if we take the derivative of the denominator, that's when we get the numerator, right? So I'm going to go ahead and call u the denominator, since the numerator is its derivative. So u is 3x to the 4th power, and then minus x cubed. So then we'll take the derivative of that. The derivative of u du equals, multiply by 4, so that's 12x cubed. That wasn't a cute noise, Bonnie. Minus, bring down the 3, subtract. All right, all of that dx. So to get dx by itself, we have to divide. So du over 12x cubed minus 3x squared equals dx. So then we'll go through and substitute in things that we can substitute in. So we've got this big ol' integral. Nothing can go in for this 12x cubed minus 3x squared. we know that 3x to the fourth minus x cubed is equal to u. So I'm going to replace u in there. Times. And then dx is equal to du over 12x cubed minus 3x squared. So I have du over 12x cubed minus 3x squared. So this piece and this piece, those are the same, so they will divide away and cancel out. So now all we're left with is just 1 over u du. So what's the integral of 1 over u, or 1 over x? Remember, we can't just add 1 to the power and divide by a new power, because then I'd be dividing by 0. So this guy, it's the natural log. So the integral of 1 over u is the natural log of u plus c. And then the last thing we want to do is replace in what we had equal to u and plug it on into u. So we'll have natural log of 3x x to the fourth minus x cubed plus c. All right, so I'll give you a couple of different ways to practice this tomorrow. I hope you guys have a good day.